A lot of scientists think Isaac Newton was the GOAT. One of his biggest achievements was figuring out how to explain how nature works with laws that describe how all objects in the universe move. How do Newton's laws of motion work? Since ancient times, Thales of Miletus was already a big name in math and astronomy. Centuries later, Galileo Galilei built on this, observing both the stars and objects on Earth. His experiments showed that weight doesn't affect how fast something falls, and he also figured out that the Earth revolves around the Sun, not the other way around. Johannes Kepler then took it a step further, precisely mapping out the planets' orbits with math. Newton's genius was taking what Galileo and Kepler had learned, and after talking with guys like Huygens, Leibniz, Halley, and especially Robert Hooke, coming up with laws that explain how everything moves. Stars, planets, you name it. Oh, and he also figured out how machines work. It all started when Hooke asked him to use his math skills to explain why celestial bodies, like the moon around the Earth, orbit the way they do. So the story goes that Newton was sitting in a field one day thinking about this question Hooke had asked him when he saw an apple fall. He thought, why down? Why not up or sideways? Then it hit him. Could the same force pulling the apple down be the thing keeping the moon in orbit? That's how he came up with the famous law of universal gravitation, which we'll talk about more later. But first, let's look at Newton's 3 laws of motion. Newton's first law, the law of inertia. An object will remain at rest or keep moving at a constant velocity unless acted upon by an outside force. It basically says that things like to keep doing what they're already doing. If something's sitting still, it'll stay still unless you push it, for example. And if something's moving, it'll keep moving in a straight line unless something bumps it or changes its path. Like, if you push a little toy car, it'll go straight for a bit, but then it slows down and stops because of friction. That's a force slowing it down. What about things moving in curves, like the moon and the planets? It's kind of the same deal, but with balanced forces. Like if you swing a ball on a string, there's a force trying to throw it outwards, the strength of your arm. But the string keeps it close to your hand. So instead of going straight, the ball goes in a circle. The moon's orbit is similar. The Earth's gravity is like the string, pulling on it. If the string broke, the ball would fly off in a straight line. Same thing with the moon. If the Earth suddenly disappeared, poof, the moon would take off in a straight line. Newton's second law, or fundamental law of dynamics. The acceleration of an object is directly proportional to the force applied to it and inversely proportional to its mass. It basically says that the harder you push something, the faster it'll speed up. So a bigger force means a bigger acceleration. Imagine a car coming along in this direction. It'll go in this trajectory. If another car with half the force bumped it from the side, and assuming it was an elastic collision, it would change its trajectory like this. If a third car hit it with even more force, its trajectory would be like this. Basically, the trajectory depends on all the forces acting on it. We can even write it as a formula. Force equals mass times acceleration. Newton's third law, or principle of action and reaction. Every action is always opposed by an equal but opposite reaction. So if you push something, it pushes back on you just as hard. Imagine you and a friend have the same weight and are on skates. If you push your friend, you'll move too. Now, if your friend is much heavier, guess who's going to move more? That biker learned Newton's third law the hard way. Ouch! Okay, so these laws make sense for things that are touching, pushing, or pulling each other. But what about apples and planets, which are far apart? Newton's big idea was that gravity is also a force, but one that works at a distance. He described it with the law of universal gravitation, which basically says the bigger the objects, the stronger the pull between them. and the farther apart they are, the weaker the pull. In other more sophisticated words, the force exerted by a point particle on another is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. The combination of these four laws has allowed the construction of all kinds of machines, the prediction of the arrival of comets, and even the construction of vehicles that have taken humans to the moon. Years later, Albert Einstein came along and showed the limits where Newton's laws didn't quite work, especially when it came to gravity. But Einstein couldn't have done it without Newton. Like Newton himself said, "If I have seen further than others, it is by standing upon the shoulders of giants." Think about it. Boom! Newton's laws demystified. Wasn't that awesome? If you learned something new today, smash that like button and subscribe for more mind-blowing science. Tell us in the comments what you want to learn next, and don't forget to ring that bell so you don't miss out on the fun. Thanks for hanging out!